Hi, my name is Brianna, and I'm a tutor here at Chegg. I tutor math and science, and if you have any questions for me, please use the link above, and I'd love to help you. So today I want to talk about acid and base properties, and just the basic, get it? Basic for base? Simplistic form, just so that it's easier for you guys to understand, like whenever you have equations for acid and bases and what that's really talking about. So let's go ahead and start with just looking at the differences between acids and bases. Acids, they're sour to taste, whereas bases are bitter to taste. So that's like the simplistic realm. I'm sure you guys tried this a little bit like in elementary school for tasting different things. Side note, do not try anything in the lab. Just trust me, if you've never tried anything acidic, it's sour. Drink lemon juice at home. Trust me, anything basic is bitter. Okay, and then also acids turn blue litmus paper red, and litmus paper is just for like pH and stuff, and then bases turn red litmus paper blue, so it's like opposite switching for colors. Acids neutralize bases, and one interesting thing for bases, it reacts with metals to form insoluble compounds, and acids produce a hydrogen ion, and then bases produce an OH hydroxide ion. And these are for if you have 100% strong acid, this is what could come out of it. So let's look at pH real quick because I do have it listed right here. So acids are a pH of 0 to 7. These are acidic. 7 is your neutral group. A pH scale, by the way, is looking at how many hydrogen ions you have. There are pOH scales, but usually we just use pH scales. So 7 is your neutral. That's what water is. And fun fact, your blood, I believe, is like 7.4. So it's very neutral as well, which is a good thing if you think about it. You don't want acidic blood in your system. If you have really acidic blood or really basic blood, I would get that looked at. So the other thing for 7 to 14, this is your basic group. And then, so let's think about different things real quick. So if you have Coke is like between 2 and 3. It's pretty acidic. And then if you have like simple cleaners, those are like 10 to 14. Household cleaners can get really acidic, like basic can get really basic, like ammonia. And so that's a really high on the alkaline form. And so know that like from 12 to 14 are your strong bases, and then 0 to 2 are your really strong acids, and everything in the middle is kind of like your weak in your middle ground. Like they're not super strong, not super weak until you get to 5 and 6 or your 8 and 9s. So it's like in the in-between unknown zone. So I hope that part all makes sense. Now let's go on to talking about the 4 different types you can have for acid-base reactions. So the first one, and my favorite, is you can have a strong acid plus a strong base. And so this is taking hydrogen chloride and sodium oxide. And through it, and here's my net ionic equation and everything, this top part's not very balanced. I didn't do it because this part is balanced. So focus on the net ionic form. I just put this here so you can see the overall realm of what's happening. This part is balanced, so go off of this. And your chloride, and you have a chloride in your reactant and chloride in your product. And then you also have a sodium in your reactant and a sodium in your product. So we can cross those out because they happen in both places. And then through our net ionic, we are left with just a hydronium ion plus a hydroxide ion, and that gets water, which is so cool because from having a strong acid, and I mean 100% of the acid and 100% base, and they're the exact same molarity, you'll get a neutral solution every single time. This will always be your end reaction for a strong acid and strong base. Super duper cool. So now let's do weak acid plus a strong base. So if you have a weak acid, here we go, HCO2H, and our strong base, OH negative. And then, since we have a strong base, our weak acid is going to have a conjugate base, which is CO2 negative. And this will make the entire reaction basic. Now let's look at for if we have a strong acid plus a weak base. Our strong acid's here, and since we have a strong acid, it's acting on the weak base to create a conjugate acid. So this is the conjugate form of our weak base. Okay? So the conjugate's coming from the weak. Same thing for if you have a strong base and a weak acid. You're getting the conjugate of whatever is the weakest. And this is making this equation more acidic. So I hope that makes sense because it's just like switching. And then for our next one is if we have a weak acid and a weak base. So from both of these, we have both of our weaks. And these are going to create a weak base from, or our conjugate base, or conjugate acid from our weak base, and our conjugate acid from our weak acid. And that's how it's switching. And so if you have a weak acid and a weak base, both of the conjugates have to be present. Whereas when you only have one, you're only going to have one of each conjugate. But if you have both of them as weak, both weak have to have conjugate base and acid. And then for the pH of this, it's going to fully depend on the relative of the Ka, the equilibrium of the acid, and the Kb values. So the equilibrium of both acid and base individually related together, and then that's how you could get the pH for it. I hope all of this made sense. If you need more help, please let me know. I'd love to help you. Have a great semester.